This is a quick overview of the Arrows web interface, which is pretty neat for using with Neo4j. I'm going to start out with a web page apcjones.com/arrows. Um, so this web interface is a little bit confusing initially, so I'm going to just show that there's a single node in the plot, and then I'm going to add a new node. That happens, and then the way that I draw an edge between these two nodes is I hover over with my mouse just outside of the original node, and then I have a new blue overlay, and I can drag from there to either a new place like that, or if I drag somewhere adjacent to the existing node, it snaps into that. So those are the two ways to create edges. Then for a given edge, I can enter a type. So let's say nose, and that sort of is the relation there. So those are how I can specify that type of relationship information. And you'll see that the graph recenters every time I sort of change where different options are in the graph. Then I can also add decorations into the node values here. So I'm going to label these with various names. And then, that's sort of the extent as far as I can tell for this web interface. That property disappeared. I don't know what happened to it right there. So this is a little bit constrained, but you can sort of see where there's an editable web interface. And then it gets a little wacky though if I have like a really long caption. So that's like a reasonable amount of text in some sense, but then it sort of makes things very large, and so there's some improvement available, I think, on this, but you can sort of get the point. And then the really interesting thing is you can export that content to Cypher. So that's all Cypher for Neo4j. So that's sort of like the cool addition here for this web interface. But you can sort of see it's not perfectly laid out in terms of like it has just sort of numerical indices. So it's sort of doing an approximation of what you really want Cypher to do. So let's go now to the Arrows.app page. And here, so there's a video tutorial. I'm going to use my necessary cookies only. And what I want to do is I want to recreate this graph, which is the relation between frequency and period from the physics derivation graph. So basically we're going to have some inference rules and some expressions, and we're going to transform those expressions to get the final result. So there's a video tutorial and a couple keyboard shortcuts, but not too many. So we're going to sort of see how this works by using it. Unfortunately, the source code is not available. If you go to the GitHub repo, it's just a README, and really what they're using it for is issue tracking. So not too helpful there, but I would really be happy if there were a open source version of this. All right, so I'm going to get rid of these existing nodes just by clicking on them and then hitting the delete key. And then so I'm going to start fresh. So I have this menu over here. So this web interface for Arrows.app is slightly different. There's a download export function, save to Google Drive, and this menu over here. So I'm going to expand and then add a node. So you can already see that's a little bit different than we had before. So I'm just going to start by clicking on a node. Then I pressed enter. And I'm going to type my math relation that I want to enter into. Okay, so just like before, I can hover over the edge and grab a new node. And I'm going to put in my inference rule here. So I'm going to click on this node, press enter, and then the caption is going to be mult both sides by. All right. And I'm going to add another node. Once I multiply that by, say, f, I'll get t f equals 1. And then I have another node over here that I want to add in. That's my feed value of f. To connect those. So now you can sort of see this is a single step with an inference rule input, a feed, and then so let's type those. So I'm going to put this as an expr and a feed respectively. And then the other thing that I'd like to do is add a property to this. So let's say sequence index 1. Alright, so there's our first step. And then I want to divide this one by t. Oops. That's and I'm going to put a feed value over here, so I'll add another value. And that's a feed. And this is an expression. Now what I'm going to get back from that is something new. I'll get f equals 1 over t. And whoop, not too far. I'll type that as an expr again. And then, so this is my second step. Let's actually be explicit about the beginning and ending of the derivation. So let's throw that in up here. Oops. I'm going to add another node, call it the end derivation, and we'll connect that. Alright, so really we have these two inference rules and two markers, and we want to have each of them have an index. So let's actually make this number 2, and then here we're going to make this another sequence index with value 1. And you can see those automatically get added as decorators outside the node. And here I'm going to have another property. Again, my sequence key, or my sequence index as a key is already available, so I just need to mark that as 3. It tells me that 1 and 2 already exist, so that's pretty handy. And then I'm going to use my sequence index again, and this will be number 4. All right. The other thing that I really want to make explicit is the fact that this is well, so let's actually fix this. So we should have expr here, and then this arrow is going the wrong direction. So let's click on reverse to reverse that, right? So now we've got the correct directionality for our nodes. And the other thing I want to do is I want to make sure that the authorship on these is clear, so that if someone made a mistake, we can go back and address that by author. So let's selected all the nodes, and then I'm going to add another property, and that property is going to be author, and then that. So you can see that automatically populates in all the nodes, so that's pretty handy. If we wanted, we could add other properties per node, but this actually is pretty complete as far as what you'd want to have on an inference, on a set of on a physics derivation graph. So now let's go to the download export option and then grab the Cypher from that. So here the Cypher looks pretty close to what you'd actually want to have for a physics derivation graph. We have the relations of the different types. We have properties on those nodes. And again, this isn't perfect, but it's quite a good approximation to build on. And you can copy that to clipboard. Okay, so this is a proprietary web interface that's very easy to use and pretty intuitive as far as how to set up the graph, and very quick.